Okay, what I ended up doing now is I lined up my holes. Pretty much I did 4, so we have a 4-pole stator. I got the first coil in, as you can see. We tightened it down, and I'm going to put all these around and show you what the stator looks like. Right now I'm just roughly cleaning up these laminates. Proper laminate, you're always going to see the lines in it. It's really thin sheet of metal. It's actually very good as far as laminate is concerned. Even the rotors are all made in the same way, and that gives the magnetic field to collapse and not be magnetized like some hard metals like drill bits and stuff like that. So when the pulse goes off and on, it actually stays off, so the domains, actually it's called domains, are all confused in a laminate metal. But a hardened one, once you put those domains in line, it becomes a magnet. So we want to use what is normally used in a motor. The housing should be a little bit heavier, but overall it's going to be pretty good, and I'll show you what it looks like when it's finished. Alright, I got the stator together, as you can see. It's a little bit bigger than the rotor, but that's okay because this is just a experiment, basically. And the rotor is going to basically, on this particular rotor, because they're off of the engine, what they have a taper shaft. So what I actually do is machine a taper shaft in here, and I'll probably go with a 1-inch output on this. So I do have a block bearing here we can use. What I'm going to end up doing is probably making a nice little wooden frame for it to hold up the stator, and then be able to use my block bearing to hold up the rotor itself and have it synchronized. Everything else I have to modify. Once I get everything set, I got to find a bearing close to this, and pretty much it's coming together. The main thing is that it's testing a theory. See, a theory is all it is. Unless you test it, it's still a theory. If it's a fact, then you have data to prove it. So everything you hear out there, an idea or a theory, always remember it's not fully tested. So it's, you know, it could work and it could not work. So this is a fun project to see if I can design a motor that can collect a back EMF, and let's see what the input versus output is under circumstances of load and everything else, because that's what it really comes down to. Experimenting, you learn a lot. If it doesn't work, you still learn a lot. So the main thing is to, instead of thinking about it, build it and then see if it works. Simple as that. And be truthful about what the output is. Don't make up a bunch of lies just to get ratings on your YouTube channel. So I'll talk to you later. Okay, what I ended up doing now, I made a 1-inch shaft, tapered it, bolted it on. It looks very nice. And basically what I'm going to do is cut some board. I want to set my bearing. I got to get that rotor in place and lined up, went to the stator. And then once I get all that, I'll mount my stator and just align it perfectly. Just as long as we got enough rotation on this where we can actually do experiments. I can make it smaller, but sometimes making it a little bit bigger you can see a lot more. So I really want to have a little space where I can actually examine a lot of the things that's going on. On this, I'll keep the little blower fan on it. Not that it really matters because it's still experimental. But who knows, if it works out pretty good, we may need it down the road. So talk to you later. Alright, this is the finished motor itself. Basically, no electronics yet, but as you can see, we tapered the shaft, put it on the rotor. Everything is all lined up, strapped it down because if there is any load, you want to make sure your stator doesn't move. Everything looks good. The bolt, that's normal. That's a normal because of when you thread them. They have a little play in them. They always act like that. But overall, we got all this. Now, I haven't done the plate yet for the rotor itself. Right now, I wanted to set up everything to get everything synchronized. And we have a very good shaft here, so a heavy-duty shaft if we need it. And pretty much, this is the basic motor design. And now it's all electronic, so I'm going to have to use the microcontroller, the whole works, to get this thing going. And my key is to actually run this as a motor generator and also capture the back EMF, because in that rotor with those fine wires you're going to have a very high spike of back EMF. Not a lot of amps, so on the stator itself you have a higher amps but lower voltage. But all this stuff can be collected if we can convert that into mechanical work, and then from that capturing the back EMF through each individual coil. So I hope you enjoy this update. Talk to you later.